Our Earth is a blue planet. Vast oceans cover most of its surface. These are not just water, they are salty seas, a complex solution. This saltiness is fundamental. It defines their very character. It shapes life within them and beyond. The sheer volume of this water is immense. It holds the key to much of our world's stability. It is a world teeming with mystery and wonder, all influenced by salt. The salt in the sea is not just a simple seasoning, it is crucial for countless marine ecosystems. Many forms of life are uniquely adapted to this saline environment, from the smallest plankton to the largest whales. Their bodies are designed to live in salt water. Unique habitats like vibrant coral reefs and deep-sea trenches exist because of this specific chemistry. The ocean's salt maintains a delicate ancient balance, carefully evolved over eons. Furthermore, the ocean's salinity plays a critical role. It influences the water's density. This, along with temperature, drives the great ocean currents. These currents act like enormous rivers within the sea. They transport heat around the globe, from the warm tropics to the colder polar regions. This circulation is vital for regulating our planet's climate. Without it, weather patterns would be unrecognizably different and far more extreme. So let us consider a profound transformation. Imagine if all this seawater suddenly lost its salt. What if the oceans became vast bodies of fresh water? This is not a trivial change. It would alter the very fabric of our planet. The consequences would ripple through every ecosystem. It would touch every form of life, including our own. We explore a world where the salt of the earth has vanished. The immediate impact on marine life would be catastrophic. Consider the fish, perfectly evolved for salt water. Their cells maintain a careful balance with the surrounding salty water. This process is called osmoregulation. If the water suddenly turned fresh, this balance would be destroyed. Fresh water would rush into their cells. The cells would swell and then burst, a grim fate for billions upon billions of creatures almost instantaneously. The devastation would not be limited to fish. Corals, those delicate architects of underwater cities, would perish. Their very structure, their life processes, depend on seawater minerals. Plankton, the base of the ocean food web, would vanish. Tiny crustaceans, shellfish, and countless other invertebrates would face the same osmotic shock. The foundations of marine ecosystems built over millions of years would crumble in moments, a silent, widespread death. Perhaps a few organisms might survive this drastic change. Some species living in estuaries where freshwater rivers meet the salty sea have a higher tolerance. They are adapted to fluctuating salinity levels. Certain bacteria or hardy microorganisms might also endure, but these would be rare exceptions. The vast, overwhelming majority of marine species, exquisitely tuned to their saline world, would be lost forever. A tragic, unparalleled extinction event. The scale of this biodiversity loss is difficult to comprehend. The oceans, currently teeming with an astonishing variety of life, would become eerily empty. Complex food webs linking predator and prey would collapse completely. The vibrant sounds of the ocean, the clicks of dolphins, the songs of whales would fall silent. It would be an ecological catastrophe of unimaginable proportions, a profound and sudden emptiness beneath the waves. Salt is a primary factor determining the density of seawater. Colder, saltier water is denser. It sinks beneath warmer, less salty water. This simple principle powers the deep ocean currents. This is known as the thermohaline circulation. It is a slow yet immensely powerful global conveyor belt. It moves vast quantities of water around the planet. This system is fundamental to Earth's climate and nutrient distribution. If the oceans became freshwater, this crucial density difference due to salt would disappear. Water density would then be governed almost entirely by temperature. While temperature differences would still exist, the engine of the thermohaline circulation would lose its primary force. The deep ocean currents would weaken dramatically. They might slow to a crawl or even stop altogether. The great conveyor belt would grind to a halt, its vital work undone. This immense system of currents is responsible for transporting heat. It carries warm surface waters from the equator towards the poles. It brings cold water from the poles back towards the tropics. This distribution of heat moderates climates globally. If this transport ceases, regional temperatures would begin to change drastically. Some areas would cool significantly, while others might become much hotter. The familiar patterns of warmth and cold would be disrupted. Beyond heat, these currents also transport essential nutrients. Deep ocean waters are rich in nutrients from decomposed organic matter. Upwelling, driven by currents, brings these nutrients to the surface. This nourishes phytoplankton, the base of the marine food web. Without the currents, this vital upwelling process would largely cease. The surface waters would become nutrient poor. This would further devastate any marine life that managed to survive the initial freshwater shock. The oceans are the great engine of our planet's weather. Vast amounts of water evaporate from their surface. This water vapor rises into the atmosphere. It forms clouds and eventually falls back to Earth as rain or snow. This cycle is fundamental to life on land. The characteristics of the ocean surface, including its temperature and salinity, influence this entire process. A change to freshwater oceans would immediately alter this. Freshwater evaporates more readily than salt water. This is because salt particles in seawater slightly inhibit evaporation. So, if the oceans turned fresh, we might initially see an increase in evaporation rates. More moisture would enter the atmosphere. This could lead to more cloud formation, perhaps even heavier rainfall in some regions, at least in the short term. The air would feel more humid over large areas. Changes in sea surface temperatures would also have a profound effect. As ocean currents falter, some areas of the ocean will warm, others will cool. These temperature differences drive atmospheric pressure systems. Altered pressure systems mean altered wind patterns. Prevailing winds could shift their course. Storm tracks, which hurricanes and cyclones follow, could move to new regions. Areas unaccustomed to such storms might suddenly find themselves vulnerable. Coastal regions in particular would experience dramatic and unpredictable shifts. Rainfall patterns, once reliable, could become erratic. Some places might experience prolonged, intense downpours, leading to flooding. Other areas could face severe and lasting droughts. The delicate balance that dictates where rain falls would be fundamentally broken. Weather would become a far more volatile and dangerous force across the globe. Our skies would be truly adrift. Section 5. A planet transformed long-term climate upheaval. The long-term consequences for global climate would be severe. With ocean currents no longer distributing heat effectively, temperature extremes would become more pronounced. Equatorial regions, normally cooled somewhat by currents bringing in colder water, would become significantly hotter. Conversely, polar and temperate regions, which receive heat from tropical waters, would cool dramatically. This would create a planet of much sharper contrasts. This cooling in higher latitudes could lead to the expansion of ice caps and glaciers. Sea ice would form more readily in freshwater oceans. This is because freshwater freezes at 0 degrees Celsius, while saltwater freezes at around -2 degrees Celsius. More extensive ice cover would reflect more sunlight back into space. This is known as the albedo effect. This could further cool these regions, potentially triggering a feedback loop leading to more ice. The ocean plays a vital role as a carbon sink. It absorbs a significant portion of the carbon dioxide we release into the atmosphere. The ocean's salinity and chemistry affect its capacity to absorb CO2. A change to freshwater would alter this complex process. It is likely that the ocean's ability to sequester carbon would be reduced. This could lead to a faster accumulation of CO2 in the atmosphere. This, in turn, would accelerate global warming trends, despite regional cooling. Ultimately, the planet would be forced to find a new and likely much less stable climate equilibrium. The mechanisms that have kept Earth's climate relatively stable for millennia would be broken. We would face a future of unpredictable swings. Extreme weather events might become the norm. The planet's thermostat, carefully regulated by its salty oceans, would be shattered. This long-term upheaval would challenge all life on Earth. Section 6. Fields of change agriculture in a freshwater world. For agriculture, the picture is complex, with initial localized benefits quickly overshadowed by widespread problems. Coastal agricultural lands often struggle with saltwater intrusion. This is where salty ocean water seeps into the soil, making it unsuitable for many crops. If the oceans became fresh, this specific problem would vanish. Farmers in these coastal zones might initially rejoice. They could cultivate land previously lost to salt. However, this small advantage would be dwarfed by larger negative impacts. The dramatic shifts in global weather patterns would be the primary concern. Reliable rainfall is the lifeblood of agriculture. If rainfall becomes erratic, with intense droughts in some areas and devastating floods in others, farming becomes a gamble. Traditional farming zones, cultivated for centuries due to stable climates, might no longer be viable. Crop yields would plummet globally. River systems would also undergo significant changes. Estuaries, the transition zones where rivers meet the sea, are currently brackish. They would become entirely fresh water. The dynamics of river deltas and lower reaches would alter. This could affect irrigation systems that draw water from these rivers. The quality and flow of water available for agriculture, even far inland, could be impacted by the changes originating in the now fresh oceans. Global food security would face an unprecedented threat. Agriculture depends on a delicate interplay of climate, water availability, and soil health. A freshwater ocean scenario disrupts all of these elements on a massive scale. The challenge of feeding the human population would become monumental. New farming techniques and locations would be needed, but the speed and scale of the changes would make adaptation incredibly difficult. Section 7. A thirst redefined humanity's new water reality. One seemingly obvious consequence of freshwater oceans is the obsolescence of desalination plants. These complex and energy-intensive facilities are currently vital for providing fresh water in many arid regions. Suddenly, the entire ocean becomes a potential source of drinking water. This appears at first glance to be an incredible boon, a virtually limitless supply of fresh water accessible along every coastline of the world. This vast new reservoir could theoretically solve issues of water scarcity for coastal populations. However, the challenges of access and distribution would remain significant. Water is heavy and difficult to transport over long distances inland. Infrastructure would be needed to pump and pipe this water to where it is most needed. Furthermore, the quality of this new fresh water would need careful monitoring, especially considering the ecological chaos unfolding within it. But this apparent abundance of fresh water comes at a terrible price. The ecological collapse of the oceans means the loss of fisheries. This is a critical food source for billions of people. The economic devastation to coastal communities reliant on fishing, tourism, and other marine industries would be immense. The benefits of free fresh water would be weighed against catastrophic losses in other sectors, a complex and often grim trade-off. Moreover, the economic systems built around saline oceans would falter. Shipping routes might be affected by new patterns of sea ice as fresh water freezes more easily. Ports and coastal infrastructure designed for saltwater conditions might face new engineering challenges. The very chemistry of the water affects corrosion and marine growth on ships. The transition would not be smooth, bringing with it a cascade of unforeseen economic adjustments and disruptions. Section 8. The domino effect cascading ecological disruptions. The transformation of the oceans from salt to fresh water would trigger a cascade of ecological disruptions. These effects would extend far beyond the water's edge. Life on land is intricately connected to the health of the seas. Consider seabirds, magnificent creatures that roam the oceans. They depend entirely on marine fish and other sea life for their sustenance. With their food sources gone, seabird populations would plummet, facing starvation. Coastal ecosystems, such as mangrove forests and salt marshes, are unique habitats. They thrive in the brackish interface between land and salty sea. These ecosystems are vital nurseries for many species. They also protect coastlines from erosion. If the adjacent sea becomes fresh, these specialized habitats would be profoundly altered. Many of the plants and animals adapted to saline conditions would die out, replaced by freshwater species, if they could colonize. The planet's great nutrient cycles would be fundamentally broken. Rivers diligently carry nutrients, weathered from rocks and soils down to the sea. In the salty oceans, complex chemical and biological processes incorporate these nutrients into marine food webs. These processes would change dramatically in a freshwater environment. The way nutrients are cycled, stored and made available would be reconfigured with unpredictable consequences for both aquatic and terrestrial life. Furthermore, the sudden death of trillions of marine organisms would create an unprecedented decomposition event. Vast quantities of organic matter would sink to the ocean floor. As bacteria and other decomposers break this down, they would consume enormous amounts of oxygen. This could lead to the formation of vast anoxic or oxygen-depleted zones in the newly fresh oceans. These dead zones would release greenhouse gases like methane, further impacting the climate. Section 9. A new Earth reflecting on a freshwater planet. If all seawater turned fresh, the Earth would become a profoundly different place. Our planet, as we know it, is shaped by its salty oceans. They influence its climate, its chemistry, and the very evolution of life. A world with freshwater oceans would be almost unrecognizable. Its rhythms, its colors, its inhabitants would be altered beyond our current comprehension. It would be a new, and in many ways alien Earth. The immediate consequences of such a transformation are almost uniformly catastrophic. For the myriad forms of marine life, it means extinction on an unimaginable scale. For the global climate, it means chaos and unpredictability with dire effects on weather patterns. For human civilization, it presents existential challenges to food security, coastal living, and economic stability. The initial shock would be devastating across all spheres. Over vast stretches of geological time, life might begin to adapt to this new reality. Hardy freshwater species could perhaps slowly colonize the now fresh seas. New evolutionary pathways might emerge. Given millions of years, a different kind of marine ecosystem could potentially develop. But this offers little comfort when faced with the immediate and total collapse of the world's current rich marine biodiversity. The recovery would be an impossibly slow process. This thought experiment, though hypothetical, serves a vital purpose. It underscores the critical importance of our ocean's natural salinity. Salt is not merely a characteristic of seawater, it is an essential ingredient for life as we know it. It drives currents, supports ecosystems, and stabilizes our climate. The delicate balance of our salty seas is precious. This vision of a freshwater world reminds us just how much we depend on them and how crucial it is to protect them.